Hello everyone. So after doing lots of stuff on differentiation or differential calculus, now we move on to integral calculus. In this video, I will introduce the concept of integration. So what is integration actually? So integration is the process of reversing the differentiation. So we know that every operation in math has inverse. For example, if you have 2 square, the inverse process is square root of 2 square, and which gives you 2. So square and square root are inverse processes of each other. Similarly, in calculus, if you have x4 and if you take the derivative with respect to, so take the derivative with respect to dx of x4, so you get 4x cube. So we say that 4x cube is derivative of x raised to power 4. But if we go the other way around, so we say that the antiderivative, so the sign of integral is this. So antiderivative or integral of 4x cube is x raised to power 4. Thus, integration is the process of reversing differentiation. So, in summary, there are two branches of calculus. The first one is differential calculus. So, where we start with a function, we apply some rules, and we find the derivative. And what does the derivative tell us? It tells us about the slope of the function. So, if you have a function like this, so derivative is the slope of the function at certain point. So this is our derivative, the slope of the function fx. So whereas in integral you start with the derivative of a function, apply certain rules, and in the end you find the function. And geometrically, what does integral mean? So integral gives you area under a function. So geometrically it gives you area under a function. So derivative gives us slope, integral gives us area. Thus when we deal with the derivatives, the first derivative, so we start with the function and the first derivative give us slope of the function. Or we also learned that, so first derivative, so that gives you velocity if you start with the displacement function, and then second derivative gives us acceleration. And also we learned that we start with the function and you take the first derivative with respect to time, so it gives you rate of change of something, so of a chemical reaction or anything. Similarly, in case of integrals, if we start with the slope of a function and we integrate that, so we get original function back. Or if you start with the velocity of something and you take integral of that, so you get the distance or the displacement traveled. And similarly, if you start with the rate of change of something and you take the integral, so you get the amount of substance formed. Amount of substance formed. So rate of change of a chemical reaction, integral of that will give you amount of substance formed. So these are the basic differences between differentiation and integration. So first we start with the indefinite integral. So this is what the notation of indefinite integral looks like. So the sign, this is called integral sign, and the function that we're gonna take the integral of is called integrand, and dx is called the differential of x, or it indicates the variable of integration. So this is differential of x, so it indicates the variable of integration, and this is equal to f capital X. So this is our antiderivative or indefinite integral. So antiderivative of small fx and plus c. So c is the constant of integration. So I'm just writing an example. So integral of 3x raised to power 5 is x6 over 2 plus c. So one thing that you need to be careful is that this integral sign and this differential, so they go together. When like you integrate it, they must appear together. So these go together while integrating. And then we have the antiderivative, and then we have the constant in case of indefinite integrals. All right, so since now we know that what does integration means, we can do some rules how to find the integration. So rules of the game. So first one is integration of a constant. So integral of k dx. So these two signs always appear together. So it means the variable of integration is x. So you can always bring the scalar constant outside. So just take integral of dx and integral of dx. What is that? So integral and differential, they are inverse processes of each other. So you can think of that they cancel each other. So you're just left with x. But since this is an indefinite integral, so we write x plus c. So integral of k dx would be kx plus c. So let's do a few more examples so you can think of what the integral is going to be. So for first one, if you want to take integral of 5 dx, so what should be the answer? So it would be 5 times integral of dx, which means 5 integral of dx is x plus c. So don't forget the constant of integration. Or you know what, you can even write in place of integral of dx, you can write x plus c, which is again 5x plus 5c. And if you think about this, so this is another constant. So rather than writing 5c, so you can just simply write 5x plus c. So what would be the integral of 2 pi cube dt? So again, 2 pi cube is just a constant, and integral of dt would be t plus c. Next we do the addition and subtraction rule of integration. So integral of fx plus minus gx is equal to integral of fx dx plus integral of gx dx. So this rule says that we can integrate one term at a time. So integral of sum is equal to sum of integrals. So if you want to find the integral of 4 pi plus 3.8 minus e squared dx, so you can write this as sum of three integrals. So you can split the terms. And so 4 pi, so plus first constant 3.8, sorry, x. So 3.8 x plus c2 and e square x plus c3. And then you can combine all the constants together, c1 plus c2 plus c3, and write that as a single constant c. So 4 pi x plus 3.8 x minus e square x plus c. So only one constant of integration is needed. Thus, if you have sum or subtraction of few different terms, so you can split the integral of different terms and then find their integral. Next, we have the power rule. What does power rule say? So integral of x raised to power n dx equals to x raised to power n plus 1 over n plus 1 plus c. So basically, we increase the power by 1 and divide by the new power. And this rule holds true when n is not equal to 1. So that means if you have something like 1 over x, so that means x raised to power negative 1. So this rule doesn't apply. So it does not apply in this case. So integral of 1 over x dx. Alright, so let's say we want to find the integral of x raised to power 4 dx. So in this case, so what we're going to do is, so x raised to power, so increase the power by 1, divide by the new power plus c. So we get x raised to power 5 over 5 plus c. Similarly, if you have integral of 1 over x cubed dx, so its x is x should not be equals to -1. So here if you write this integral in the power form, so x raised to power -3 dx, but still it's not -1, we can still apply the formula. So x raised to power -3 plus 1 over -3 plus 1 plus c, which means we get x raised to power -2 over -2 plus c, or in other words, ½ x square plus c. Similarly, if you have a fractional power, so here we have integral of x raised to power 3 over 7 dx. So we're going to do the same thing. So increase the power by 1, divide by the new power plus c. So we get x raised to power, so 10 over 7, so 10 over 7 plus c, or you can bring 7 up. So, and if you want, you can write this as x raised to power 10, 7th root of that, over 10. So this is your solution. Thus, power rule applies to any powers except when the power is -1. So far we have learned three rules for integration. So integration of a constant is constant times x plus c. Addition rule, so you can integrate one term at a time. And the power rule is that you increase the power by 1 and divide by the new power plus c. And the next video, I will discuss the general power rule, or also you can think of that as a U substitution. So make sure you watch that video as well. So if you like my videos, please subscribe to my channel. See you next time.